Hey guys, today I'm going to be showing you how to make a simple not inverter. So let's crack on. Hey guys, welcome back to another day, where today we are going to be talking about the NOT gate, also known as an inverter. So it's also known as an inverter. It has only one input, that is A, and one output, that is A inverted. And the symbol is, well, a small triangle with a circle at the top. Its truth table is, when A is high, the output would be the inverse, or what's in opposite to high, low, therefore 0. And if the input is 0 or low, the output will be 1 or high. So that's the truth table. So the simple transistor diagram of this is going to be this, where we have a 5-volt power supply and everything is taken reference to ground, which is 0 volts. There is our first A, that is going to be a switch. Then there's a resistor feeding into a base of the transistor, that's an NPN. The emitter is connected to ground, while the collector is connected to another resistor with a 5-volt power supply, and the negative of the power supply is connected to the ground. From the resistor, we have taken our output, that is A inverse. So we'll be making this circuit diagram. It's pretty much the same. So as you can see, we have just connected every single ground together, because this is not like sticking a pole into the literal ground. It means that all the grounds are connected to one single spot, that is the negative. So it's something like this. Hopefully I've done it. And here's this. So the transistor I'm using is C1815. So it's pretty easy to get. And the resistors are 6K and 160 ohm. For the first battery, I'll be using 3 volts. And for the second, I'll be using 9 volts. So before making this, let's check out how it works. So in the diagram, it's pretty simple. When A is not connected anywhere, so this is a simpler diagram. When A is not connected anywhere, the battery, the positive, this is the positive. The positive current flows like this. Because it can't go through the transistor, it has to flow through the diode, and it's actually a light emitting diode or an LED, and goes into ground, which is connected to the negative. And the cycle repeats. So when the input is 0, we get an output of 1, shown by the LED. But let's suppose we connect them. The circuit is complete. And this is also 5 volts. So this is the positive and this is the negative. So now a positive voltage is being fed into the base of the transistor, which opens the collector emitter path, which allows the positive current to flow through the resistor and through the transistor onto ground, therefore shutting off the voltage going in this direction and allowing the current to go in this. So that's how it works. So let's build it. Okay, after about 10 minutes of soldering, I've created this. As you can see, the resistor is connected to the base through the positive of this battery case, and the negative is connected to the emitter. This is on this side, and this resistor is connected to the collector, and another black wire which is connected to this supply, which is going to be a 9 volts, is also connected to the emitter, and the LED is, the positive lead of the LED is connected to the resistor and collector both, and the negative of the LED is connected to the negative. So yeah, it's pretty simple, as you can see. It wasn't that hard to build. So first, let's give it a try. So now I'm gonna attach this. Come on. Oops. Okay. As you can see, there is no input. That means the output is 1 or high, which is denoted by the LED. Same in this case, when the switch was on. Sorry, the off. So current goes from here to there, like this. Same as in this case. But if we put the battery, get another one, and you will see as soon as this battery is put, the circuit is closed. Or when the input is 1, the output is off or 0. Because again, if the battery is connected, like the switch is connected, and it allows the current to pass through collector and emitter junction. That's why this is closed. So it's pretty cool. And if you show this in a science fair, you're most definitely gonna get 1. Not 1, actually you're gonna get an A+, and hopefully you'll be selected for the second round, if there is. But it's way better than making a baking soda volcano. It's classic, but this is really cool. You can also tell your teachers or the judges that it can be used in homes. Like if the 220, just suppose that this is 220 volts, and so is this. This is the inverter. So if the line, I'm just going to call this line, if the line is active, you can just power appliances from this. And this is the inverter, and it will be charging like this. But once the power goes out, like this, oh sorry, it's not connected. Once the power goes out, you can take an output from this. So that means you can still power your appliance with this, even though there is no out. This is what is exactly in your home, but on a much bigger scale. But instead of using an LED, they use a relay, and when there is no power, the relay switches off and current can flow from there. You can just use a simple 5-volt relay that can withstand 220 volts, and you can put it here instead of the LED, the 2 coils. And you can put the 220 volts in the normally open and the center point. Let me just show you, I'll be back. So you can make this. So this is a step down transformer that is feeding into a full bridge rectifier, which gives about 5 volts and some amount of current. So we'll use another current dropping resistor, the same switch. It's exactly the same circuit, but we replace the LED with a relay, and we connect one end to a light bulb, and the normally closed switch is connected to nothing, while the normally open switch is connected to one side of your inverter battery, and the other side of your lamp is connected to the other side. So in this, that means when the 220 volts is feeding into this, it feeds into the transistor, which allows current to flow from this. And it only works on 9 volts. Because the relay needs 9 volts. If you have a smaller one, then congrats. So if for any case, let's suppose a blackout happens, and you can't get any voltage out of it, like you get only 0 volts, then the transistor will switch off, and the 9 volt can go through the collector and emitter path. So it will be forced to go through the coil of the relay, and then it will switch. Where's the pencil? Where's my pencil? Okay, found it. It will go through the relay, and it will switch the relay on like this, therefore turning the light on where there is no inverter. And yeah, this is like a auto detection. And then you can also have a switch here, or MCB type, that tells you like if the blackout and it's night and you want to sleep but the lamp is on, you can just flick this switch so your inverter battery doesn't drain and you get a sound sleep. So yeah, you can also make this, which can be used for homes, or just simply make this that I made. It's pretty useful. So as you can see, should have disconnected the battery. So if there is a blackout, the inverter will power things. Well, if the line is on, the inverter gets charged. Because it's not a rechargeable battery, I have not put the charging circuit, though you can. And the LED turns off, indicating that there is light, or the 220 volt is on. So it's pretty simple, and I encourage you to make this. And if you like my video, sincerely, I just want you to help me grow my channel. So it'd be awesome if you subscribe to my channel, and also tell other people that you care about my channel so they can learn more. So I hope you like this video, and don't forget to like, share and subscribe. Goodbye.